Today, we will talk about Bayes' theorem. Bayes' theorem, named after 18th-century British mathematician Thomas Bayes, is a mathematical formula for determining conditional probability. Conditional probability is the likelihood of an outcome occurring, based on a previous outcome having occurred in similar circumstances. It provides a way to revise existing predictions given new or additional evidence. In finance, it can be used to rate the risk of lending money to potential borrowers, and it also is the foundation of the field of Bayesian statistics. Applications of Bayes' theorem are widespread and not limited to the financial realm. Bayes' theorem provides the probability of an event based on new information that is or may be related to that event. The formula also can be used to determine how the probability of an event occurring may be affected by hypothetical new information, supposing the new information will turn out to be true. For instance, consider drawing a single card from a complete deck of 52 cards. There are 4 kings in the deck, so the probability that the card is a king is 4 divided by 52, which equals 1/13 or approximately 7.69%. If it is revealed that the selected card is a face card, the probability the selected card is a king, given it is a face card, is 4 divided by 12, or approximately 33.3%, as there are 12 face cards in a deck. Bayes' theorem follows simply from the axioms of conditional probability. For example, a simple probability question may ask, what is the probability of Amazon.com stock price falling? Conditional probability takes this question a step further by asking, what is the probability of the Amazon stock price falling given that the Dow Jones Industrial Average Index fell earlier? The theorem can also be applied to pharmaceutical drug testing. As a numerical example, imagine there is a drug test that is 98% accurate, meaning that 98% of the time, it shows a true positive result for someone using the drug, and 98% of the time, it shows a true negative result for non-users of the drug. Next, assume 0.5% of people use the drug. If a person selected at random tests positive for the drug, Bayes' theorem shows that even if a person tested positive in this scenario, there is a roughly 80% chance the person does not take the drug. The theorem was discovered among the papers of the English Presbyterian minister and mathematician Thomas Bayes and published posthumously by being read to the Royal Society in 1764. Bayes' theorem provides a useful method for thinking about the relationship between a data set and a probability. It says that the probability of a given hypothesis being true based on specific observed data can be stated as finding the probability of observing the data given the hypothesis multiplied by the probability of the hypothesis being true regardless of the data, divided by the probability of observing the data regardless of the hypothesis. Here are 5 key takeaways. 1. Bayes' theorem allows you to update the predicted probabilities of an event by incorporating new information. 2. Bayes' theorem was named after 18th-century mathematician Thomas Bayes. 3. It often is employed in finance in calculating or updating risk evaluation. 4. The theorem has become a useful element in the implementation of machine learning. 5. The theorem was unused for 2 centuries because of the high volume of calculation capacity required to execute its transactions. Hope this would help. Thanks for watching.